Hey class, the last time you saw me, we were at the horse races. And now I'm going to explain what happened in that iodine reaction at the microscopic level. Let's look at the players first. Here we have sodium bisulfite. Sodium bisulfite. That H in the center is what signifies that bi part. Next up, potassium iodate. Next is dihydrogen monoxide, but we're going to say water. And then a simple starch solution prepared with water, and it's a potato starch, but not that that matters. This reaction is actually two different things going on at once, and that's why it's so instantaneous, the color change. The first reaction is the iodate ions are reacting with the bisulfite ions, and they're producing iodide ions, hydrogen ions, and sulfate ions. That's the slow reaction. The fast reaction is down here at the bottom. It's hydrogen ions that are produced up here, plus the iodide ions, again, produced in that one, plus more of that iodate from the first reaction, produce iodide and water. This is the key player right here, iodide. No ion, just iodide, I2. So let's look at these first. They're not balanced. This one's a lot easier to balance. Let's do it first. We just have HI and O. Hydrogen on this side, we got 1. On this side, we have 2. Iodine, 1, 2. Over here, 2. And then oxygen, 3. And 1. Okay, we've got hydrogen and iodine as wild cards, so let's fix oxygen first. We need 3 on the product side. Put a 3 right there. 3 times 2 makes 6 hydrogens. Come over here. Put a 6. And that's all she wrote. Fill in your gaps. 1s, 1s, 1s. Easy as that. This one, a little bit more tricky. First up, we've got iodine, oxygen, hydrogen, sulfur. Iodine, 1, 1. Oxygen, 3 plus 3 is 6. Over here, 4. Hydrogen, 1, 1. Sulfur, 1, 1. Okay, so it looks pretty simple, except oxygen's screwed up. Now, if we look over here, we've got O3 and O3. That can be odd or even. If you look over here, O4 can only be an even number. So anytime we make an odd number of oxygen on this side, we can go ahead and scratch that off. We have to have an even number. So obviously 4 and 6 don't balance. Can we make 8 on this side? 3 and 3, nope. What about 12? Can we make 12? We can, if we simply put 2 here and 2 there, because that's 2 times 3 and 2 times 3. 6 plus 6 is 12. Now, Can we match that on the product side? We sure can. We put a 3. 12. That changes sulfur to a 3. And over here, sulfur is a 2. There are no more sulfurs to get extra from this side. So what that tells me is this coefficient and this coefficient have to be the same. So that's not going to work. Let's keep going up. What if we did 4 would give us 4 times 4 is 16. And there's no way to make 16. What about 4 times 5? 20. Again, there's no way to make 20 with 2 3s. What about 24? That could be a possibility. Change this to 6. That's 24. And then, again, this has to be the same as that. So we're going to have to put a 6 here. That gives us 6 times 3 is 18. We need 24, which means we need 2 more. 2 times 3 is 6. 18 plus 6 is 24. We got the oxygen taken care of. Update our totals. 2I to 6H and 6S. Go over here, 6 sulfur. And then for the others, they're wild cards, we just change them. Hydrogen needs to be a 6. Iodine needs to be a 2. Now, 2, 6, 2, 6, 6. Those all can be reduced. Should we reduce them? We should. What if we did 1 and 3? We could change that to a 1, a 3, 1, 3, 3. Now let's check that, see if it works. 1 iodine, 3 oxygen, plus 9 is 12. 3 hydrogen. And 3 sulfur. Over here, 1 iodine, 3 hydrogen, and then 3 sulfur. 3 times 4 is 12 oxygen. Look at that. So it's kind of ugly, and we had to go the long way around, but we made it work. Now back to what's actually going on here. These iodate ions combined with the bisulfite are producing iodine, hydrogen, and sulfate ions. The key players are the iodine and the hydrogen ions, because when they get combined with more of that iodate, they're producing iodide. That's the diatomic form of iodine. And then water, it's produced as well. We had it at the beginning. So the key player here is the iodine. Once we run out of this bisulfite, iodine completely reacts immediately with the starch. But even though the starch is present, as this bisulfite is getting eaten up one after the other, it keeps that iodine from completely reacting with the starch. But once the bisulfite completely is used up, that iodine immediately triggers a reaction with the starch, which is what produces the bluish black color. Now, some of you may be saying, what happened to potassium and sodium? They're not in either one of these. They're not important. They didn't play a part in this reaction. We call them spectator ions. And as you can tell from the name, a spectator ion just watches the reaction happen. So we've got sodium and potassium. Now, I hope this makes sense. It's hard to understand. There's actually a third reaction taking place that we're not going to talk about. But the main two, reaction one, the slow one, reaction two, the fast one. And that's how we had our horse race iodine reaction.